Today we will be looking at a question from the 2008 exam. This is the 2008 AB exam. And it is classified as type 2 particle motion question because we're asking questions about particles increasing, decreasing, acceleration, as well as I've classified this also as type 3, and type 3 is calculus and interpreting graphs. So we have a graph here that we're going to use to interpret our data. So let's jump into it. Particle moves along the x-axis so that its velocity at time t is given by the differentiable function v, shown above. The velocity at times 0, 3, and 5 is 0. So at these locations, velocity is 0. And has horizontal tangents at time 1 and time 4. So at time 1, we have a horizontal tangent, and at time 4, we have a horizontal tangent. The areas of the region bounded by the t-axis and the graph of v on the intervals 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2 respectively. So this region is 8, this region is 3, and this region is 2. At time 0, the particle is at a position of negative 2. So write that here, x of 0 equals negative 2. Okay, we've extracted info, put it on the graph. Jumping into part A. For 0 to 6, find both the time and position when the particle is farthest to the left. Justify your answer. So farthest sounds like an extrema, and we're looking for, left would be the minimum. So we're looking for the absolute minimum. And absolute minimum, or absolute extrema, that would be occurring either at the endpoints or at critical values. So absolute extrema occur at endpoints or critical values. So let's find out where our absolute minimum is. So we're going to look for the position at the endpoints, as well as our position at any critical values. Now, a critical value is where the derivative of the function equals 0. So the critical values for this position function would be 3 and 5. Okay. Now, if we analyze this a little bit, this is the derivative of position, and so if we're going negative to positive on the derivative, we know that we are decreasing to increasing. So this has the potential to be a minimum. But at time 5, our derivative is going from positive to negative, so that would mean that the position is going right to left, which makes this a maximum. So this will not be an absolute minimum. So we don't even need to test x of 5. Now you can, it's just extra work. Okay, x of 0 they give to us. X of 0 is negative 2. Let's work with x of 3 first. X of 3 is going to be where I started plus what I accumulated from 0 to 3 of the derivative of position. So this will be negative 2 plus negative 8, which gives me a value of negative 10. So, and I pulled that negative 8 because that's the value of that region. We're going forward and below, so it's a negative integral. Okay. X of 6 would be x of 0 plus what I accumulate from 0 to 6 of my derivative, or my rate function. So we start at negative 2. We're going to lose 8 in the first chunk of the graph, and then gain 3 in the next chunk of the graph, and then finally lose another 2 in the final chunk of the graph. And this comes to a total value of negative 9. The question says farthest to the left, so we're looking for the absolute minimum. specifically, I'll write that there, minimum. So -2, -9, -10. Looks like -10 is the minimum. The particle is farthest left. At t equals 3, x of 3 equals -10. Okay, so there's the absolute minimum. All right, moving on to part B, it says how many values between 0 and 6 is the particle at -8? Explain your reasoning. So it looks like we're looking for the existence of a position of -8. And we'll turn to our existence theorems for this, specifically the existence of a x of t equaling -8. So it doesn't look like we're looking at the derivative, so my initial instinct is that this is a intermediate value theorem question. And the intermediate value theorem says that if a function is continuous between a and b, and a point exists between f of a and f of b, then we're going to pass through it somewhere. So let's write this down. Since x of t is continuous on 0 to 3 and -8 is between x of 0 and x of 3, there's one occurrence there. We pass through once. And we'll take a look at the next interval again, and x of t is continuous on, let's look at the interval from 3 to 5. -8 is between x of 3, which equals -10, and x of 5, which is going back up to the graph. If the position was -10 here and we've accumulated 3 more units, we would go up to -7. So -7. So we passed through it twice, and then from 5 to 6, we go from -7 position to -9 position. Sorry. Yeah, -7 to -9. And x of t is continuous on 5 to 6 and -8. It's between x of 5 equaling -7, x of 6 equaling -9. It's 3 times for which x of t is equal to -8. Okay, one other thing that is probably worth looking at is the fact that this says how many times and not at least how many times, and this is getting really technical. I don't know if they'd get to this level of technicality with grading. If you'd written this down, that would be very specific. But we know that since velocity is negative on the interval 0 to 3, the curve is moving monotonically, which means x of t is decreasing for this entire interval. So there's not going to be an occurrence where it passes through a value of -8 once and then goes up, and then passes through a value of -8 twice and then goes back down, passes through -8 3 times. because it's monotonic, it's only going to pass through it one time between 0 and 3, one time between 3 and 5, and one time between 5 and 6. So this idea of being continuous will give us the existence of at least one value. If we say monotonic, then it's going to occur only one time in that interval, monotonic. And I don't know if they're going to get to that level of precision in the grading, unfortunately. I have not been a grader yet. Hopefully soon.
I went on Space Mountain 17 times.
All right, let's look at part C. Part C says, on the interval 2 to 3, is the speed increasing or decreasing? So, speed is increasing if x prime of t and x prime prime of t share signs. Or another way to say that is if v of t and v prime of t share signs, or if you want to use velocity and acceleration. So speed will be increasing if that's the case here. Speed is decreasing if those things don't share signs. So let's take a look at what we're asking. It says on the interval 2 to 3. On the interval 2 to 3, v of t is less than 0. Looking at the graph, 2 to 3, v of t is less than 0. And v of t is increasing, i.e. v prime of t is greater than 0. Therefore, v of t and v prime of t do not share signs. Do not share signs. Speed is decreasing. Okay. So that's part C. Give a reason for your answer. The reason is right here. V of t is less than 0, but v prime of t is greater than 0. So speed is decreasing when we don't share signs, and we are not sharing signs between velocity and acceleration. Finally, looking at part D, during what time intervals, if any, is the acceleration of the particle negative? So in part D, acceleration is negative if v prime of t is negative. And we know that because the derivative of position is velocity and the derivative of velocity is acceleration. So that relationship there, acceleration is negative if v prime of t is negative. Okay. So we're looking for when is v prime of t negative? Well, v prime of t is negative where v of t is decreasing. That's a functional relationship. A function will be decreasing, therefore its derivative is negative. So we want to look at the graph here and see if there's any intervals on which this function is decreasing. And we do have an interval. We have an interval from 0 to 1, flat spot at 1 they give us, as well as from 4 to 6, flat spot at 4 because they give us. So this occurs on the interval 0 to 1 and 4 to 6. Okay, let's look at how this gets graded. We'll jump back up to part A and grade part A. So part A, you're given 3 points in part A. The first point comes from, did you identify 3 as a candidate? So by identifying 3 as a candidate, you'll get 1 point. The second point comes from, did you consider the accumulation from times 0 to 6? So that's worth 1 point. And then finally, your conclusion. The conclusion is farthest left at time 3 where the position is -10. Recall you need both the time and the position to get that point. Okay. Moving on to part B. Part B is also worth 3 points. You need to show the position at time 3, time 5, and time 6. So you need to show those 3 positions to get the first point. The next thing is to describe the motion. So continuous and monotonic motion. Perhaps if you use the word increasing or decreasing, that might also qualify for describing the motion, but describing the motion is part of that point. And then the last one is the conclusion, which is there exists 3 times. So that's a pretty wordy one. Okay, moving to part C. Part C is worth only 1 point, and the point is the answer with the reason. Okay, so you have to answer that the speed is decreasing, and if you answered that correctly, they'll look at the reason, and if your reason is correct, then you get the point. Only 1 point. Okay. Part D. Part D is worth 2 points. This one is your answer and then your justification. So the answer is, here's the answer for 1 point, and then the justification is v prime of t is negative where v of t is decreasing. And you probably also, I should put that in there, show the relationship between velocity and acceleration. That's something you should actually do with all of the particles in motion question. You should start off by declaring the relationship between position, velocity, and acceleration. All right, sorry this one was a little bit longer than my usual videos, but I hope it was helpful. And be sure to smash that like button, hit the bell for notifications, comment, subscribe, buy my merch if I ever drop some merch, and have a good day.